Okay, so we'll go through this review today. Monday is your opportunity from 11:30 to 12:30 to do your reassessment for Unit 3, and then Wednesday will be your opportunity to do your trig reassessment. So on Tuesday, we'll go through the trig exam, um, and then Thursday we'll go through the review package. I will post the completed package for transformations on Google Classroom because we're not going to have time to go through that. So I will post that on Google Classroom so you can go through that and check the answers there. Yep.
The sheet wasn't for the test round, maybe they tried to, so do you need
Pardon me?
do you need to know if we're doing the exam right if the
Yep.
board didn't get the sheet around?
Well, I printed off a scan sheet for everyone, so no, I don't, as long as you have the review assignment to work on. Okay? So, exponents and logarithms. Number one, graph of y equals 3 to the x is reflected in the line y equals x. The equation of the transform graph is what? So you have to remember that when a graph reflects over the line y equals x, that describes the inverse. When you take the inverse of a function, it will reflect over the line y equals x. To get the equation of the inverse, our first step was to interchange x and y. So that's the first step, to get the equation of the inverse of y equals 3 to the x. If you look at the four choices that you have, though, they all have y by themselves, so that's what we need to do. And to do that, we will convert from exponential to logarithmic by starting with the base and cycling through. The bases are the same. The exponential function has a base of 3, so the log will have a base of 3. It'll be log base 3 of x equals y, which is 8. Right? So again, you have to remember that the inverse reflects over the line y equals x. Reflecting over the line y equals x is the inverse. Do you need one of these packages? No, you just want to deface school property.
No, this is how I get in and out.
Okay. Number two, what is the value of that? So the first three terms, you could just put those in your calculator to get the value of them, but the last two have variables. So you've got to understand a few things about logarithms to do that. But the first term, log base 5 of 625, is asking 5 to what power is 625? I believe it's 4, yes. And you can check that, 5 to the power 4, yes. Or you can also use the calculator if you have the newer operating system. Go log base 5 of 625. Or you can use the change of base identity, log of 625 divided by the log of 5. No matter which way you do it, this is 4. Plus 3 times log base 7 of 49 will be 2. That's asking 2 to what power is 49? Or you could use your calculator to see that log base 7 of 49 is 2. Plus, log base 2 of 1/16 will be negative 4. That's asking 2 to what power is 1/16? And it will be negative 4. But you can use your calculator to get that as well. Log base 2 of 1/16. What's log base b of b equal? Yeah, why?
That's what the power to something is.
That's asking b to what power is b. That's one way to look at it. What's another way? You sound so confident. Well, you should be, because that's correct. If you use the change of base identity, it'd be log b divided by log b. You're dividing something by itself, it's 1. Okay, smarty pants, what's log base a of 1 equal?
Oh, you're asking me.
You're smarty pants. B? Ask Skylar. She knows everything. Why is it 0, Skylar?
Oh wait, it's hard to.
Okay, just cut her off. Don't worry about her. She'll be fine. Don't worry about her feelings.
No, I remember now. That was. Go ahead then.
Oh yeah, go ahead then. Okay. You've totally deflated her. Her self-esteem is gone.
I never meant it to be allowed. Because anything to power 0 is 1.
Right. That's asking a to what power is 1. Anything to the power 0 is 1. So the 4's will cancel. You'll get 3 times 2, which is 6, plus 1 is 7. Number 3 is a standard of excellence question. You are going to have to convert from logarithm to exponential, but first you have to get the log part by itself by dividing both sides by m. And then you can start with the base and cycle through. It'll be p to the power q over m equals n. So that's why B was the correct answer. I do, but you'll have to come back at the end of class and bring $5 too. Rank these in order from least to greatest, so you can use your calculator to find out what the value of each is. Some of them will be irrational. So log base 4 of 62 will be irrational, approximately 2.98. Log base 6 of 36 would be, that's asking 2 to what power is 36. The next two will be irrational. Log base 3 of 10, 2.1 approximately, and log base 5 of 20. Approximately 1.9. So from least to greatest, it'll be log base 5 of 20, log base 6 of 36, log base 3 of 10, and log base 4 of 62. So there they are from least to greatest. Number 5, what is that expression equal to? Well, you're multiplying powers with the same base, so you would add the exponents and keep the base the same. Doesn't matter that the exponents are logs, you follow the rule. Now that's not one of the 4 choices we have. However, when you're adding logs with the same base, you can use the product law. This will be the same thing as 3 to the power log of x times x, or 3 times the log of, or 3 to the power, of log x squared. So that's why A was the correct answer. Question 6, write as a single logarithm. So a couple things we'll do here. We'll bring all the coefficients up as exponents, and we'll also rearrange to put the positive terms first. 2 log x will be log of x squared. Then I'll put the plus 3 log y, which is a log of y cubed. Normally we put the positive ones first, followed by the subtraction, the negative one. And this negative log z over 2 is the same as negative 1/2 log z. 1/2 is a coefficient. It can come up as an exponent, power 1/2. So using the product and quotient law, we can combine all the terms together. Whoops, I really screwed that up. Try that again. Log of x squared times y cubed over z to the half, which is the root of z. So that's why A is the correct answer. Because of the minus sign, we use the quotient law. Okay, number 7. Given that log base 3 of A is 6 and log base 3 of B is 5, what is the value of log base 3 of 9AB squared? So that 9AB squared is a product. You've got 3 factors there, 9A and B squared. So using the product law, you can expand. You'll have the log base 3 of 9 plus the log base 3 of A plus log base 3 of B squared. Log base 3 of 9, that's 2. That's asking 3 to what power is 9? We are told that log base 3 of A is 6. The last term, though, we're not told what log base 3 of B squared is. It's log base 3 of B is 5. So you can bring the 2 in front using the power law, and then it'll be 2 times 5. So you'll add those together and get 18 is the answer. Remember, if this was a numerical response question, you go left to right. The first 2 boxes will be filled. The last 2 will be empty. And the computer marks what you bubble below. So you've got 8 hours to write this exam. 6 hours to write this exam. Go back and check all your bubbles on your multiple choice and your numerical response. Students work to simplify a logarithmic expression as shown. Where did they make their first error? So step 1. If you bring the coefficients up as exponents, x to the 4th all squared would be x to the 8th because you have to multiply the exponents. Minus, when you bring this coefficient of 3 up as an exponent, x squared all cubed is x to the 6th. And for the last one, same thing. It'll be log base A of x to the cubed all to the 4th, which will be x to the 12th. I would rearrange the terms to put the positive ones first. And now, because you are dealing with logs all with the same base, you can use the appropriate laws. It'll be log of x to the 8th times x to the 12th divided by x to the 6th. You add the exponents together on top, so it's going to be x to the 20 over x to the 6th, and at that point you will subtract the exponents. 20 minus 6 is 14. So if we check the work as we go through here, right, the second step is correct, but the third step is where the error was made in the third step. So from step 2 to step 3. Number 9, the equation for the asymptote of that graph would be what? So you have to remember kind of what the graph of a logarithmic function looks like. The graph of log base b of x will have an x-intercept at +1. The y-axis is an asymptote. And the graph will look something like this. What b does is it changes how steep or flat the graph gets. That's what b does. That's what we saw when we looked at different graphs. The y-axis, the line x equals 0, is the asymptote. This equation, x is replaced with x minus 3, which means it'll go 3 to the right. The value of h is the opposite of what it appears to be because, remember, in the general form, it was always x minus h. So the value of h here will be positive 3, which means the graph will shift 3 to the right. Shifting it up 2 doesn't change the asymptote because the asymptote is a vertical line. Just shifting it 3 to the right. So therefore your asymptote is at x equals 3. Number 10, the graph of y equals log x is transformed to that. So normally we would get the y by itself by adding 4 to both sides, which compared to y equals log x, here we have an h value of -5. It'll go 5 to the left and then 4 units up. So that's why B was the answer. Number 11, the reason this is a standard of excellence question is you must take B out as a common factor to determine what the H value is, right? So again, we know what the graph of y equals log base B of x looks like, right? We graphed it above there. So for this graph, to find H, 3 must be taken out as a common factor, which means it's going to be horizontally stretched by a third, which will not change that asymptote, but it's also going to be shifted 4 to the left. So now the asymptote will be at x equals -4, and the domain will be x is greater than -4. It doesn't matter what kind of function you're dealing with. B must be taken out as a common factor to get the H value. The y-intercept is always where x equals 0. So if you let x equal 0 here, you're going to have a to the 1 plus b, which is a plus b. There's almost always a question on diploma exams where we have to find the x or y-intercept of some function. Number 13, this one can be done by making the bases the same. 8 is 2 cubed. 4 is 2 squared. So for that first one, you're going to multiply the exponents. Same thing for the second one. And now we've expressed both sides as single powers with the same base. This is an equation. The two sides are equal. If one part are equal, the other parts are equal as well. They have equal bases, so the exponents have to be equal. And then we solve for x. Subtract 2x from both sides, subtract 12 from both sides. X will equal -30/7. There's the answer, which you can always check this. -30/7 is that decimal. If we put these equations in our calculator, 8 to the power 3x plus 4 and 4 to the power x minus 9. Zoom 6, set our windows to their standard settings, and find the point of intersection. It's a decimal, and if we recall it here, it's exactly the same as the answer we got algebraically. So our answer is definitely correct. Remember on the written response, if it says algebraically determine or just determine, you have to show your work. Now for this one, you cannot make the bases the same. This is why it's a standard of excellence questions, because you have to use logarithms. So you got two options. You can take the common log of both sides, then use the power law to bring the exponents in front, multiply them out, collect all the x's together on one side, common factor of x, and then divide to get x by itself. Or you can start with the base and cycle through. So if we start with the left side as our exponential function with a base of 3, and from that we cycle through. So as a logarithm, it'll be log base 3. After that comes our 1/5 to the power x minus 3 equals 2x plus 1. The advantage of doing it this way is you only have one log. You only have to use the power law on one side. It cuts down a bit on the amount of algebra that you have to do. So again, that x minus 3 exponent comes in front as a coefficient. You'll multiply out the brackets. You want to collect the terms with x together on one side, which means I'll subtract the 2x from both sides. On the right side, I've got a 1 plus, I'll add the 3 log base 3 of 1/5 to both sides. Remember, we're trying to get x by itself. So on the left side, I'll take out a common factor of x. Out of both terms. And then divide both sides by what's inside the bracket. So it says round to the nearest hundredth where necessary, so that's what we will do. So the numerator, I'll put in brackets as 1 plus 3 times the log with a base of 3 of 1/5. And we got to close the bracket on the numerator and then divide it by the denominator in brackets. Log base 3 of 1/5 minus 2. So 0.98 to the nearest hundredth. You cannot cancel the log base 3 of 1/5 because you'd be breaking up parts of binomials. You can only divide by all the terms in a binomial, not just one of them. So approximately 0.98 to the nearest hundredth. So remember, you put the decimal in that second box. There is a space between the second and the third boxes for decimals. That's the only place. And you'd have to bubble in the decimal there. Number 15 has to solve that algebraically. So on the left, you're adding logs with the same base. You can use the product law to combine them. So that'll be log base 7 of x squared minus 4x minus 5. And now we will convert from logarithmic to exponential. We'll start with the base and cycle through. Subtract the 7 from both sides and we'll have x squared minus 4x minus 12 equals 0. Solve that by factoring. So according to that equation, we have two solutions, 6 and negative 2, but x can't be negative 2. You cannot take the log of a negative number, nor can you take the log of 0. The restrictions on this equation would be that x has to be greater than negative 1, as well as x has to be greater than 5. We would use the one that satisfies both, which is that x is greater than 5. So that's one of the reasons why negative 2 won't work. That is an extraneous root. Only x equals 6 works.
but I see. Or is it the same thing?
That means it's a combination of acceptable and standard of excellence. All right, earthquake intensity given by that formula, where I sub 0 is the reference intensity, m is the magnitude. An earthquake measuring 5.3 on the Richter scale is 125 times more intense than a second earthquake. Determine to the nearest tenth the Richter scale measure of that second earthquake. So I sub 1 will equal I sub 0 times 10 to the power 5.3. The second one, I sub 2, will equal I sub 0 times 10 to the power m. We are told that the first one is 125 times more intense than the second one, which means if we divide the two equations, if we divide I sub 1 by I sub 2, that'll be 125. Because the first equation is 125 times more intense than the second. So if you divide their intensities, you'll get quotient of 125. When you divide the I sub zeros, they cancel. And when you divide the powers with bases of 10, you subtract the exponents and keep the base the same. So it'll be 10 to the power 5.3 minus m. And now we want to solve for m. And we can do that by starting with the base and cycling through. We're going to change from exponential to logarithmic. The exponential function has a base of 10, so this log will have a base of 10. It'll be log base 10 of 125 equals 5.3 minus m. Log base 10 of 125, well, you can just use your log key, right? That's a common log, which your calculator is programmed to evaluate. So that's 2.097. That equals 5.3 minus m. We'll subtract the 5.3, and we'll get negative 3.2 equals negative m. So m equals 3.2. That's the magnitude of the second earthquake. Okay. Number 17 says it's a standard of excellence question. The population of the town on July 1 of 2011 was 20,000. The population is decreasing at an average annual rate of 1.4%. How long would it take the population to reach 15,300? So if we use the exponential growth and decay formula that's on the formula sheet, that's y equals a times b to the power t on p. Y is the final amount, which in this case is our 15,300. A is the initial amount, which is 20,000. B is the growth rate. Now, this is why this is a standard of excellence question. It said it's decreasing by 1.4%. B, though, is not what it's decreasing by, it's what the population is being maintained by. If it's decreasing by 1.4%, that means it maintains 98.6% of its population. That's the number you have to use. So B is our growth factor, which in this case will be 98.6% or 0.986. T is the time, which is what we're looking for here. How long will it take? And P is the growth period, which in this case, this population is decreasing by that percentage every year. So the growth period is 1 year or 1. So if we put all these in to the formula, it's just going to be T over 1, or T. And we need to solve for T. Starting with dividing both sides by 20,000. So 15,300 divided by 20,000 is 0.765. That'll equal 0.986 to the power T. And then to solve for T, we'll convert to logarithmic. We'll start with the base and cycle through. The exponential function has a base of 0.986. That'll be the base of the log. So it'll be log base 0.986 of 0.765 equals T. And so rounded to the nearest year, 19 years. That's how long it'll take for that population to go down to 15,300. Okay, so you can work on the package that has the questions in it. And Monday from 11:30 to 12:30 is your opportunity to rewrite Unit 3, so make sure you have the review assignment done.
Sorry, so Tuesday we're going to be doing the, just looking over the
Trigonometry exam.